This is Mrs. Naslund, and today we'll be doing Unit 7, Lesson 6, Making Sense of Remainders. Our learning target for today is, I can understand different ways to incorporate remainders in division. So basically, we're going to be looking at different types of problems and making sense of the remainders and how they're used in the problems, because they can be used in many different ways. So let's go through a couple of different situations. It says, remainders in division have different meaning depending upon the type of problem you solve. The same numeric solution shown to the right works for the following 5 problems. Discuss why the remainder means something different each time. So here's the problem we're going to be looking at. And the 5 problems we're going to look at all follow this exact equation, and this remainder of 1 means different things for each problem. And you have to be able to read each word problem critically in order to decide what the remainder means. So, first one, A, it said the remainder is not part of the question. Thomas has one 9-foot pine board. He needs to make 4-foot shelves for his books. How many shelves can he cut? So he has a 9-foot pine board, and he wants to make each shelf 4 foot long. How many can he cut? And the answer is he can only cut 2, right? Because even though he has a remainder of 1, it wouldn't be enough to make a full shelf. So in this case, the remainder isn't even used at all. We could say he could cut 2 full shelves. He can't cut any more, or it wouldn't be a full shelf. In B, it says the remainder causes the answer to be rounded up. So it says 9 students are going on a field trip. Parents had offered to drive. If each parent can drive 4 students, how many parents are needed to drive? So we have 9 students total, and there are 4 parents willing to drive. So if I do our division, we get 2. So they need to divide 2, but then there's a remainder of 1. So what does that mean for us? Well, it means that it's necessary for there to be to use 3 cars instead of 2. We can't leave one kid on the side of the road and not have him get there. So we have to use 3 full cars because that one kid can't be left without the bus. So you can see in this case, the remainder we had to round up in order for everyone to have a spot in a car. In this case, it says the remainder is a fractional part of the answer. One Monday, Kim bought 9 apples to school. She shared them equally among herself and 3 friends. How many apples did each person get? All right, now this one's kind of complicated. We're going to actually go to another page here to talk about this one in a second. But basically, she has 9 apples, and she wants to share them equally among 3 of her friends. How many apples did each person get? Sorry, herself and 3 friends. So she wants to share them equally among 4 people. So she did her division. So we know that each person gets 2 apples. Then what do we do with this remainder of 1? Okay, and the answer is we actually make it into a fraction. We know that there are 4 people total, and we have a remainder of 1, and so we're going to make it into a fraction. This is the part, and this is the number of wholes that we have, so we're going to make it into 1/4. So all the people, each people are going to get 2 whole apples, and then each person is going to get 1/4 of an apple. I'm going to actually jump to another page here so we can look at this more closely. Here we go. And then we can practice it. So let's see. It says, this is the one we just practiced, but let's try some other ones. The next Monday, Kim bought 13 apples to share equally among herself and 5 friends. How many apples did each person get? So in this case, again, it's herself and 5, so there's 6 people, all right? We're going to divide it into 13 because there were 13 apples total. I know that I can't do 6 into 1, but I can do 6 into 13. I know it goes in 2 times. And I multiply. 6 times 2 is 12. And I do the sister subtract step. And I get a remainder of 1. All right, so each of the 6 people for sure get 2 apples. But now we have to figure out what fraction of the last apple they each get, okay? And again, the trick to this is you look at your remainder, there's 1, You look at the number of people that you started with, which was 6. And so you make it into a fraction. So I'm going to put the 1 from here over 6. So each person will get 2 and 1/6 of an apple. All right, let's try one more. All right, this one says, the next Monday after that, Kim bought 17 apples to share equally among herself and 7 friends. How many apples did each person get? So again, it's herself and 7, so there's 8 people total, and we're dividing it by 17 apples. And I know that 8 goes into 17 2 times. Multiply, 8 times 2 is 16. I subtract, and I end up with 1. All right, so a remainder of 1. So of her 8 friends, we know that everyone's going to get 2 whole apples. And then what is the fraction that they would get? So I want you to think about that. You can hit pause and try it. All right, the fraction that they would get would be 1/8. So each person would get 2 and 1/8 of an apple. And again, I got the 1 for my remainder, and I know that I have 8 people total, so I get 2 and 1/8. Great job. All right, let's go back to our scenarios here. We still had 2 more to go. The remainder is a decimal part of the answer. All right, so Raul brought 4 toy cars for $9. Each car cost the same amount. How much did each car cost? All right, so you'll see that they've changed it from 4 into 9, but it's 4 into $9. All right, and how much did each car cost? So I'm going to actually show you this again on a different page. I'm going to break it down, and I want you to see decimals as just an introduction. We'll come back to this later, but I want you to see it so you can kind of understand how they came to these answers. So we're going to start off dividing. We write our 4 into $9. You'll see we put the decimal in there, and then we go ahead and follow the steps. So 4 goes into 9 2 times, and then I multiply. 4 times 2 is 8, and I subtract, and I get 1. Okay, so how many dollars are in the answer? How many total dollars are in the answer? Well, the answer is 2. Okay, so we have $2 in the answer, and we're going to keep going here. Step B, I've subtracted, I get 1. Now, once you see this decimal, I bring it straight down, and then I put the 0 here. Just pretend you're always going to keep that decimal in line like that, okay? But when we look at this number, we're not going to look at it as 4 into 1. We're going to look at it as in 4 into 10. So it's brought down, but just pretend like this is just one regular number in long division, okay? So I think 4 goes into 10 how many times? First we're going to answer this. How many dimes are in the leftover dollars? So how many dimes is that? The answer is 10 dimes, right? So there's 10 there, all right? So then we go ahead and we've got our dollar. Then we go ahead and divide. We say, how many times does 4 go into 10? It goes into 10 2 times, so I write the 2 up here, and then I do my multiply step. 4 times 2 is 8, and then I subtract. And I want you to notice 10 minus 8 is 2. I just keep moving that decimal down, okay? So how many dimes are in the answer now is the question. And now there's 2, all right? So then, last step, I come over here, I've subtracted to 2, and now I go ahead and divide again. This time it's 4 into 20, and 4 goes into 25 times. Then I multiply. 4 times 5 is 20. I subtract, and I get 0. So how many pennies are left over in the dimes? And the answer is 20. All right. And how many pennies are there total in the answer? And the answer is 5, right? Because those are the pennies, those are your tens, and those are your dollars. So you can see that you can actually divide using decimals as well. And in this case, the remainder then, we don't have a remainder, but we end up with the actual decimal amount in a dollar. All right, we got 2 more scenarios here. All right, the remainder is a decimal part of the answer. Okay, oh, we did that one, sorry. So we got that one. Yep, we ended up with a car costing $2.25. All right, the last one is the remainder is only part needed to answer the question. So this one is the only thing we need to answer the question. Let's read an example and see why. 9 students have signed up to run a relay race. If each relay team can have 4 runners, how many students cannot run in the race? So we're doing our division. 4 goes into 9 2 times. So this is our 2 teams of 4 people, and we have 1 person left out. And they want to know how many students can't run. Well, only 1 student can't run. So that remainder ends up being that extra person that can't run. All right, great work. All right, so let's practice what we know with some real-world division problems. So here's the first problem. Maddie tried to divide 160 stickers equally among herself and 5 friends. There are some stickers left over, so she kept them. How many stickers did Maddie get? So when I read this problem, what I understand is that I'm going to figure out how many stickers each of her friends got, and then she gets to keep the leftovers. The leftovers are going to be our remainder. So let's go ahead and do the problem. She has, among herself and 5 students, so she has 160 stickers. And because it's herself and 5 others, it's 6. We're going to divide it by 6. So 6 goes into 16 2 times. 6 times 2 is 12. And I subtract. I get 4. And I do my bring it on down. I get 0. Then I go 6 into 40, which 6 goes into 46 times. 6 times 6 is 36. And then I subtract. I'm going to end up with 4. I borrowed here to make this a 3. So 10 minus 6 is 4. So I end up with 26, remainder of 4. Now, you want to jump to the conclusion that she gets 26, but there are some stickers left over and Maddie kept them. How many stickers did Maddie get? So she had 26 when she divided equally, and there are 4 extras. So if she's keeping those, I get to add those up. 26 plus 4. So Maddie ended up with exactly 30 stickers. All right. Lastly, let's do this last problem. Kendra bought a bag of 200 cheese crackers for her class. If each student gets 7 crackers, how many students are there and how many crackers would be left over? So why don't you go ahead and pause and solve for yourself. All right, let's see how you did. So she bought a bag of 200 cheese crackers for her class. If each student gets 7, it's 200, and divide it by 7. So 7 goes into 22 times. 7 times 2 is 14. Then I subtract. This is a 1, change this to 10. 10 minus 4 is 6. And I'm going to bring on down this 0. All right, and 7 goes into 68 times. 7 times 8 is 56. I do my subtracting. And this becomes a 5. Becomes a 10. 10 minus 6 is 4. So I end up with 28, remainder of 4. So now let's look at the problem again. So first question was, how many students are there? Well, now we know there are 28 students, and how many crackers are left over? Guess what? That's a remainder. There are 4 crackers left over. So today we learned about what remainders can look like in different problems, and then we applied them to some real-world problems. So great work, and you can go work on your homework.